Okay, so here's the question. If 2.5 grams of sodium hydroxide and zinc nitrate are dissolved in water in separate beakers, and 1 gram of a solid is filtered, dried, and weighed, what's the percent yield? Now this is going to require a lot of calculations. And the first thing we're going to have to do is to figure out what our limiting reactant is. In the process of figuring out the limiting reactant, the way that I teach it in this class, we will have determined, or we'll be able to determine what the theoretical yield is all at the same time. Okay? What we need to do is to do 2 stoichiometric calculations, starting with the 2.5 grams of sodium hydroxide. That's the first one. And the second one is starting with 2.5 grams of zinc nitrate and finding our way mathematically to the mass of the product we're seeking. Well, we don't yet know what that is. We've got to figure that out. And the way we do that is by writing a balanced equation. This problem doesn't even tell you what the identity of the solid is. You have to figure it out. So the first thing we want to do is to write the 2 formulas. Sodium hydroxide. Sodium is Na, has a 1 plus charge. Hydroxide is OH, has a 1 negative charge. And so you only need one of each of those to have a balanced formula, so that's NaOH. Zinc is Zn. If you look on your periodic table of oxidation numbers, you'll find that zinc has only 1 oxidation number, which would be implied by the fact that I have no Roman numeral there anyway. Because if it had more than 1 oxidation number, we'd have to have a Roman numeral. But zinc has a 2 plus charge here. Okay, so that's 2 plus. Nitrate is found on your common ions list in your test references. Nitrate is NO3 with a 1 negative charge. In order to balance this formula, I'm going to need 2 nitrates because there's a 1 negative charge on it, where zinc has a 2 plus charge. To get a neutral charge in the compound, I need 2 of these polyatomic ions. I've got to have a compound that has no charge overall when you put everything together. So I'm going to need 2 of these, and that gives us zinc, and nitrate is in parentheses with the 2 following it. Okay? So those are going to be our 2 reactants here and here in the problem. So I'm going to leave a little space so I can balance the product formulas too. NaOH and ZnNO3 Now the problem states that these are dissolved in water. Now, you can look it up on the solubility rules and find out whether it's soluble or not, but it says it's dissolved, so we can assume it's aqueous. Both of these are going to be aqueous. Okay? So I have 2 two-part compounds here. Even the name tells you that. Sodium hydroxide. Sounds like 2 parts. Sodium, OH together makes a hydroxide. So that means that's a 2-part compound. Zinc and nitrate, 2 parts. If we have 2 two-part compounds, the first thing you're going to assume is you're going to have a double replacement reaction. In addition to that, it says we're going to have a solid form. Well, that's a precipitate, and that happens more often than not in a double replacement reaction. It does happen in single replacement reactions too, but not quite as often. Not quite in the same way. Anyway, so we're going to put Na with NO3. I haven't checked it balancing it. I'm just putting the 2 parts together and the zinc with the hydroxide. But I need to balance those formulas. Okay? So Na, we said, has a 1 plus charge. NO3, we showed up here, has a 1 negative charge. So that's going to be pretty simple. NaNO3. A 1 plus and a 1 negative gives you a 0 charge, or a neutral charge, and that's what we want. The zinc, as we said up here, has a 2 plus charge. And the OH, we said up here, has a 1 negative charge, the hydroxide. So we're going to need 2 of these. In order to have a neutral compound, we've got a 2 plus charge and a 1 negative charge. We need 2 of these negative charges to balance out the 2 plus charge. So zinc and the OH, then it goes in parentheses with a 2 after to show we have 2 hydroxides. So down here, that's what I'm going to do with that. Now we are going to have to use the solubility rules. You have a simple set of solubility rules in your test references. Okay? And the very first rule, in fact, the very first thing that's listed here is nitrates. It says nitrates are always soluble. There are no exceptions in this part of the rule. If they're soluble, it means if there's water around, it's aqueous. So this is going to be aqueous. As it turns out, it also says group 1 salts are always soluble, and that's a group 1 element there, so this is a group 1 salt. Zinc hydroxide. Hydroxides are down here, and it says hydroxides are insoluble. That means when there's water around, they're going to form a solid. There's exceptions for group 1 strontium and barium, but obviously zinc is not group 1. It's not in the first column of the periodic table. It's not strontium or barium, so this is going to be a solid. Hydroxides are generally insoluble, and there's no exception for a zinc hydroxide. So this is the skeletal equation. This is before we balance the equation. Now we're ready to balance the equation, and for balancing equations, we always use an atom inventory. We're going to list all the elements in this equation. We've got an Na, we've got oxygen, we've got hydrogen, we've got zinc, we've got nitrogen, and here's oxygen again. We don't need to list it a second time. And we make the grid for the atom inventory. And we count the elements we have. We've got 1 sodium, 1 oxygen here, but over here we have how many oxygens? 6. If you can't keep up with that in your head, and please don't feel bad if you can't, I have to write them down separately very often, especially if I'm tired. So 1 plus, and then 3 inside the parentheses times the 2 gives us 6. So that's a 7 total oxygens on this side. I've got 1 hydrogen. I've got 1 zinc, and I've got 2 nitrogens. Anything inside the parentheses with the 2 outside means that you're going to multiply that number by the 2 outside, whatever's on the outside here of the parentheses. On the other side of the equation, then, we've got 1 sodium. We've got 3 oxygens here and 2 here. Oxygen. 3 here plus 2. So we've got 5 oxygens at the moment. We've got 2 hydrogens. We've got 1 zinc. And we've got 1 nitrogen. All right, the rule that I've given you on balancing equations is you always balance oxygen last. You don't have to list it last, you balance it last. And you balance hydrogen next to last. So the place we're going to start then is with the nitrogen. I've got 2 on the left and only 1 on the right. In order to get 2 nitrogens on the right, at this point, the formulas are balanced. We can't touch the formulas. You can't put any subscripts or coefficients inside the formulas. You can only put coefficients in front of the formulas to balance the equation. So I can put a 2 here on the outside. That will multiply everything inside by 2. So now I have 2 sodium. Well, let's see. I'm going to change the sodiums, the nitrogens, and the oxygens here. So I've got 2 sodiums now. I've got 2 nitrogens. And the oxygens, I now have 3 inside the formula times 2, that's 6. And 2 times the 1 inside the formula gives me 2. So at the moment now I have 8 oxygens on this side. Alright, so in balancing the nitrogens, I've unbalanced the sodium. And we're going to save oxygen for last and hydrogen next to last, so we need to start with sodium now. In order to get 2 sodiums on the left to match the 2 on the right, I can only put a coefficient 2 out in front. I can't put anything inside the formula. That's going to change the number of sodiums, the number of oxygens, and the number of hydrogens. So now I have 2 sodiums. The oxygens are going to be a bit complex. I'm going to make a separate calculation down here. 2 times the 1 in the formula gives me 2 oxygens here, plus the 3 times the 2 over here. So I have 8 oxygens. And the hydrogens, I now have 2 times the 1 in the formula, that's 2, and everything is now balanced. Okay? Any questions so far? All right. We're at the point now where we can start doing the stoichiometry. I like to do the stoichiometry as a 1-part problem, but I'll allow you to do a 3-part problem if you want to. Okay? I want to do it as a 1-part problem. What we need to do is start with the 2.5 grams of sodium hydroxide and find the amount of the solid produced, because what we're looking for is the amount of the solid here. The solid we've identified now as zinc hydroxide. So the problem didn't tell you it was zinc hydroxide. You had to figure it out. And then separately, we're going to do a mass-to-mass calculation starting with 2.5 grams of zinc nitrate to the sodium hydroxide. And by doing that, we're going to identify the limiting reactant and the theoretical yield. So let's start with the 2.5 grams of sodium hydroxide, 2.50 grams. And your starting amounts always go over the number 1. Not 1 mole, not 1 gram, not 1 Richie, 1. Just the number 1. It's a placekeeper. Okay? On the test, even after saying that over and over again, I had some people who still put it over something besides 1. We need to know the molar mass of sodium hydroxide in order to do the next conversion. So I've got to list sodium, oxygen, and hydrogen, and find the atomic masses of those. And you find that on the periodic table. It's the bottom number in every block for that symbol. For sodium, it's 22.989769. Oxygen is 15.9994. Hydrogen is 1.00794. In this formula, there's only 1 of each. You don't look at this coefficient up here. This coefficient has nothing to do with the molar mass of the formula. The coefficient only has to do with balancing the equation and a molar ratio step we'll have in this calculation in a minute. But for calculating molar mass of sodium hydroxide, you don't worry about this 2. You don't worry about the 2. I have people doing it in the test, even after saying that. I'm just trying to be really, really, really clear. Okay, you don't worry about the 2 when you're calculating molar mass. So we've only got 1 of each of these things here. Well, actually, I need to line all these up nice and neat. Say what? I know I want to erase the 1 because I needed to move it over. I need to put a 7 here instead of a 9 as well. Now, I guess my whiteout's a little bit, didn't shake it up.
You found it?
No, I got another bottle of it.
Oh.
I actually had 1 stuck away somewhere. I didn't realize I had it stuck away. Alright, so now we're ready to add all those up, and we're going to have to find the right number of significant digits for our answer. So if you're just sitting there watching me and not doing this math, shame on you. You should be practicing every time. The more you practice, the more likely you are not to make those silly mistakes that we just talked about, among those we just talked about. So I got 39.997109. I didn't line up my digits very well. I should have done that. I'm kind of used to doing this. So I got a little sloppy here on you. I apologize, but you should line up your digits really, really neatly so that you can see where the empty slots are. If you do so, and I didn't do it, I apologize for that, you'll find you have 2 empty slots over here.